Welcome back to the deep dive. Today, we are wrestling with a really fundamental challenge facing pretty much every organization trying to build modern AI. And that's just the sheer complexity of the infrastructure transformation.
It really is.
Yeah.
It's the enterprise equivalent of trying to build some holistic machine using parts from, say, 5 different factories that were never meant to speak the same language.
Right.
You've got these cutting-edge models, diverse software connectors, all these specialized accelerator cards, GPUs, FPGAs, whatever, and they exist in their own silos.
So, trying to line up your big organizational goals with a cohesive end-to-end AI strategy, it ends up feeling like you're solving a puzzle blindfolded.
Completely.
Yeah.
And that is exactly our mission for this deep dive. We're going to investigate the singular technology that, based on all the material, really promises to unify this chaos.
To make that whole integration puzzle a lot less mysterious. And it seems the key to unlocking the full holistic power of AI. It lies in this shift toward using AI agents.
That's the critical distinction. It
Yeah.
really is. When most people think of AI, they're thinking of a traditional model, right?
Mhm.
An LLM or a computer vision model.
Yeah.
And that is inherently reactive.
You give it an input, it gives you an output.
Exactly.
Yeah.
It's purely predictive. AI agents, on the other hand, are fundamentally different.
Ah.
They are initiative.
Initiative. Okay, that's a massive semantic leap for a piece of code. I mean, if a standard LLM can already process information and generate text, what specific capabilities does that initiative quality unlock? What changes the game from it being just a tool to being an autonomous orchestrator?
It all starts with memory and goals. Unlike a traditional model that just forgets everything between prompts, an AI agent is goal-driven. It's context-aware.
So it remembers.
It maintains both short-term memory, the immediate steps it's taking, and long-term memory.
Yeah.
And that's what allows it to learn from failures, to reflect on past actions, and actually adjust its future behavior.
Yeah, I see.
And that capacity for reflection is what lets it plan these complicated, multi-step workflows.
So it's not just responding to a single command like summarize this document. It's responding to a high-level objective, something like process this claim and notify the client, which could take 20 different steps.
Exactly.
That planning ability. It really reminds me of what the source material called the digital conductor. It orchestrates all the components without necessarily, playing every single note itself.
That's a fantastic analogy.
Mm-hmm.
And the agent's power isn't just in making the plan. It's in the autonomous execution and the resource management.
The follow-through.
Right. It makes a complicated plan, and then it has the power to interact with the broader software ecosystem, that whole network of tools and hardware, to actually get those steps done.
And that overcomes that historical complexity of trying to bolt AI onto existing enterprise infrastructure.
It does. I mean, if the entire headache is combining different use cases with the optimal mix of models, software, and hardware, then the agent is essentially automating that optimization process.
So strategically, what does that really mean?
It means we stop building custom glue code for every single interaction. Think about the payoff for a CTO or a head of engineering.
Right.
They no longer need a massive human team just dedicated to manually testing, configuring, and maintaining the perfect hardware configuration for every single step of a business process. The agentic AI can autonomously assemble the optimal combination.
So the human engineering effort shifts. It goes from the tedious configuration and maintenance, the plumbing, to actual creation and innovation, designing the workflows themselves.
Precisely. And the core payoff is just enormous. You see much higher inference and decision accuracy because the agent is always picking the best fit resource for the job.
And lower costs, I assume.
Oh, significantly lower overhead and operational costs because the hardware is being used efficiently and all that manual management just disappears.
That sets the stage perfectly. So let's talk about where and how these agents operate, because we're not just talking about another SaaS tool here.
Yeah.
What exactly is this network, this enterprise ecosystem they interact with?
The scope is, it's pretty staggering. A single AI agent can interact with virtually any digital component an enterprise possesses.
Like what?
Well, this includes external interactions, like communicating with APIs to access third-party apps or connecting to huge databases to query data and stage models. Using external cloud resources is, well, that's just table stakes for them.
And crucially, they interact locally too, right? We can't forget the internal architecture.
Absolutely. They interact with software running locally on the specific server or computer, the box the agent program is actually on. But here is where we get into the deep integration that makes agentic AI so unique.
Okay.
In some advanced cases, the agent can interact directly with the firmware controlling some of those highly specialized AI accelerator cards.
Whoa, hold on. Let's unpack that for a second.
Mhm.
Firmware control. Because that sounds like you're giving the software some truly deep power.
It is.
Interacting with an ATI is like calling a vendor for a part. Interacting with local software is like adjusting a machine on the factory floor. But firmware?
That's correct. Firmware control lets the agent go way beyond just sending data to a card. It gives it deep resource management capabilities.
So it can adjust parameters, optimize scheduling.
It can even activate specific low-level functions within the silicon itself. It provides this highly efficient control over hardware utilization, ensuring that specialized models run with maximum speed and minimal latency. It often bypasses the standard operating system bottlenecks.
I have to jump in here and ask the critical governance question. If an agent is autonomously assembling resources and operating at the firmware level, doesn't that introduce a massive security risk? Or a stability risk, giving one piece of software that much control over the hardware stack?
That's a really important question,
Yeah.
and it's exactly why these systems are developed within secure, highly governed environments. The goal isn't reckless autonomy, it's constrained autonomy.
Okay.
The agent's access is strictly managed through defined toolkits and permissions, often using what's called a sandboxed environment. The agent isn't given, root control of the machine.
I see.
It's given specific monitored permissions to execute tasks via authorized interfaces. That ensures stability and auditability are maintained through the whole process.
That clarifies the governance framework. Okay. Now let's move to maybe the most fascinating layer of this ecosystem. Agents interacting with other agents. This suggests, it's like a corporate structure being replicated digitally, specialization, delegation.
And that agent-to-agent communication is the foundational element that lets us build truly holistic solutions. When an initial agent, let's call it the orchestrator, determines a task needs a very specific skill set it doesn't have.
It doesn't just call a standard model.
No, it delegates that entire subtask to a specialized AI agent.
So it's handing over the whole project, not just a line item.
Exactly. The specialized agent then takes ownership of that delegated task. It communicates with the necessary components, a database, a cloud resource, local software, to execute its subtask. Once it's done, it reports back, returning control and the results back to the original initiating agent.
And that's what allows us to solve these complex real-world problems that require so many different skills.
It's the only way.
This is where the rubber meets the road. We absolutely need a concrete example to visualize this whole autonomous planning and delegation chain. Let's take that workflow we mentioned, modernizing the claims process for a big car insurance company.
Perfect. So we start with the primary AI, let's call it the AI claim agent. When this agent receives the initial data images, text, docs, driver info, it immediately engages its goal-seeking capability and it autonomously plans the entire workflow.
Okay.
And this single workflow involves steps that need wildly different AI capabilities.
Yeah.
Parsing text, matching complex legal policies, image processing, fraud detection, auditing, and then finally, sensitive client communication.
Okay, let's walk through its choices, starting with the first thing it needs to do, parsing the claim, just extracting key facts from unstructured damage reports.
Right. For parsing, the agent recognizes it needs robust natural language processing, NLP. It needs to be quick and scalable. So if the enterprise has a third-party, specialized NLP model running efficiently in a public cloud,
It just sends it out.
the claim agent delegates that initial parsing task to that external cloud resource. That's delegation choice 1. It's prioritizing scale and external specialization.
Okay, next up, policy match. This means comparing the facts of the claim against, hundreds of pages of dense, complex policy language to make sure it's covered? That just screams large language model.
It does. An LLM is ideal for that legal complexity.
Mm.
But now, privacy and latency are critical.
Of course.
So if the claim agent is running on an enterprise system that has specialized PCIe accelerator cards, optimized specifically for running LLMs locally, which reduces latency and keeps sensitive data inside the security perimeter,
Then it uses that.
the agent interacts with the local system manager to offload that policy matching work to that specific internal optimized card.
So it's actively prioritizing low latency and data security over the generalized cloud resource it used in the first step. It's like smart procurement.
Absolutely. Next, we have image processing. The agent needs to analyze photos of the damaged car, assess the damage, maybe flag inconsistencies. This requires massive parallel processing.
Right.
The agent sees that a dedicated bank of high-performance GPUs is available in the infrastructure. It routes the massive image workload to those GPUs for rapid processing. Delegation choice 3.
And fraud detection. That's often a real-time requirement for highly specialized, often proprietary models.
Precisely. Fraud detection might involve extremely fast, highly optimized algorithms. It could be that the ecosystem includes specialized silicon controlled by dedicated firmware for these unique fraud models.
So it talks to the firmware.
The claim agent leverages its ability to interact at that deep level, communicating through the resource manager or directly with the firmware to send the task to that specialized card for lightning-fast processing. This is why that deep hardware integration we talked about is so vital.
It then logs all these results in the audit step, which means database interaction confirming every delegation and outcome is recorded. But that brings us to the final human-facing step, client interaction.
Right.
The skills for deep analytics, legal matching, hardware optimization, they are worlds away from the skills you need to communicate sensitive results to a client who might be upset or confused.
And that is the ultimate test of agentic AI. You need empathy, you need clarity, and you need the ability to interact with client-facing applications. The claim agent is optimized for analysis and resource management. It recognizes that these communication skills require a different set of tools and models.
Maybe a language model fine-tuned for tone and empathy.
Exactly. So the solution isn't for the claim agent to try and become a customer service rep.
Yeah.
The solution is creating a second, specialized AI agent, the client interaction agent. The claim agent delegates that final task, communicating the results clearly and compassionately to this new, specialized entity.
And that new agent is equipped with the specific tools it needs, like access to client portals or CRM databases, to deliver the outcome effectively.
Perfect input.
This single, complex example perfectly illustrates how agentic AI solves the infrastructure puzzle itself. It autonomously assembles the optimal sequence of resources, cloud models, local specialized hardware, databases, and critically, other specialized agents to form one cohesive, end-to-end business solution.
That really is the core synthesis of this deep dive. When you break the concept down into these components, memory, goal-driven planning, deep delegation, and resource assembly, you see that agentic AI isn't just hype.
It's the real deal.
It's the infrastructure glue. It drives massive increases in both efficiency and decision-making accuracy by letting the system use the right tool on the right hardware at exactly the right time.
It's the automation of strategic optimization. And it sparks a final question for you, the listener, to consider. If a single AI agent can successfully manage and delegate tasks to 5 different specialized models, pieces of hardware, and even other specialized agents to solve a problem like a car claim, what new levels of workflow complexity and cross-functional integration can agentic AI unlock for future possibilities in truly massive distributed enterprise systems?
We'd love to hear your thoughts and suggestions on this. What territory do you think agentic AI will transform next? Share your insights in the comments below.
That's all the time we have for this deep dive. If you enjoyed this conversation and found it helpful in understanding the future of AI infrastructure, please do us a favor. Hit that like button, subscribe to the channel, and turn on notifications so you don't miss our next deep dive.
And share this episode with anyone else who needs a shortcut to being well-informed.
Thank you for joining us.